Hey everyone, this is lesson 7, understanding equations. So we've been saying the word expression a lot, and now we're going to be talking about the word equation. So for essential questions, we've got a few. What is an equation? How can we write an equation from a word problem? And how can we tell if a solution is correct? You're going to want to pause this as you write the essential question and then the key terms. So pause it now so you can write this down, and then each of the key terms. Some of these are very familiar and some of them might be new. So I'm going to scroll, that way you can rewind or go forward whenever you best see fit. So here are all the definitions that you're going to need for your vocab. Okay, a variable is a letter that stands for a number. Equation, it's just a statement of equality, so saying that two things are equal, two expressions are equal. Usually we think of variables in equations. Number sentence is numerical expression, so not with variables, but same thing, two expressions that are equal. And then solution, that's the number that if we plug it back in or substitute it back in, it's going to make a true number sentence. Okay, turn to page 52, and we're going to talk about this, just this one problem here. We're not going to do all the problems with the opening exercise, but we are going to do this first one. Your brother's going to college and you no longer need to share a bedroom. You decide to redecorate a wall by hanging two new posters on the wall, which are right here. The wall is 14 feet wide and each poster is 4 feet wide. So you need to figure out what is the equal distance between the poster and the wall, between the two posters, and between the poster and the wall over here, because you want to place the posters so that the distance is the same in all three of those places. So what we're going to do is we're going to kind of come up with a way to solve it, which would be 14 feet. We want to take away the two poster lengths. So 14 minus 4 minus 4, and that leaves us with 6 feet. So what that means is that this piece, and this piece altogether has to be 6. So we would divide 6 by 3, and then that's it. 2 feet in each space. Okay, and you can kind of see right here, if I take this and this and this, that would give me 14 feet altogether. So if you can, go ahead and label that. So 2 feet, 2 feet, and 2 feet. So that's just a quick example of working backwards. If you wanted to write the official equation for that, there were 3 equal spaces there. So what they'll call that 3x, plus the 8 feet from the posters, altogether would be 14 feet long. Okay, so that's the equation version of what we did here, what we did up above in blue. Okay, I actually don't want to do the rest of the examples on 52 and 53, so you can cross those out and jump on over to 54. We're going to talk about another word problem, and this one is about the ages of 3 sisters. So you can imagine 3 sisters, and their ages are consecutive integers. That word consecutive always tricks kids up. You have to know what it means, really. You cannot get it right if you don't know what consecutive means. So consecutive means in a row. For example, 9, 10, 11. Now, I didn't give you the answer, of course, I wouldn't do that, but I'm just giving you an example of what their ages could be. So if they're 3 consecutive integers, that's 9, 10, 11. The reason it can't be 9, 10, 11 is because the sum of their ages is 45. And 9 plus 10 plus 11 isn't 45. But we can draw a diagram, we're going to draw a tape diagram actually, to help us understand how we can figure out the age of all the kids, all the girls. So what I'm going to do is make a box for the youngest. Okay, I'm going to label it youngest. Now think real quick, the middle sister, how much older, how many years older is she than the youngest? What does consecutive means? It means just one more. So we're just going to put a 1 here. Okay, if we call the youngest x, the middle child would be whatever x is plus 1 more. And then what would the oldest be? The oldest is going to be one more than the middle. So do you see how it keeps going up? Keeps going up by one. All together, their ages are 45 years. Okay, so down below, we know that the youngest sister is X years old. And then how would we explain the middle sister? So let's use Y, let's write out youngest because Y is a variable. That would be confusing. Okay, so the youngest is X. The middle is X plus 1. And the oldest would be X plus 2. Because there's the youngest, her middle sister is a year older, and her oldest sister is 2 years older. Okay, so what we can do is we can actually write an equation. Go ahead and underline that. Write an equation that can be used to find their ages. And what that means is all of these together, they told us that the sum is 45. So if I add the youngest, which is X, plus the middle sister, which is X plus 1, plus the oldest sister, which is X plus 2, all together their ages are 45. Okay, now that we have a couple diagrams, we're going to actually figure out the youngest sister's age. You might have already done that, but if you haven't, here's an explanation on how we can do that. So the youngest up above in the tape diagram, plus the middle, plus the oldest, all equals 45 years. So what we can do here is we can do 45. We can take away these 3, and that gives us 42. That gives us 42. Okay, and then we have those 3 x's. So if I do 42 divided by 3, it gives me 14. Okay, remember, you can always pause things and then, because anytime you want to try it on your own, but this is new, so that's why I'm doing everything with you. Okay, so now if we go back to C, it says determine if your answer from part A is a solution to your equation in part B. So we got an answer for part A. So 14, that means the youngest is 14. And now we're going to see if that actually works. So we're going to determine if our answer from A is a solution to the equation in B. So basically we're plugging in, every time we see X, we're going to plug in 14. So 14 plus, there's another X, 14 plus 1, and then another X plus 14 plus 2. So we think that the sisters are 14, 15, and 16. So try 14 plus 15 plus 16. And we want that to equal 45. And if you want to show each step, that's always a good idea. And yes, 29 plus 16 is 45. Okay, so that works. So the sisters are 14, 15, and 16. Okay, not too bad. Let's move on to page 55. Sophia pays a $19.99 membership fee for an online store. If she also buys 2 songs from a new album at a price of 99 cents each, what is the total cost? Okay, so she pays a membership fee. That's it. That's a one-time thing. She pays a membership fee, and she buys 2 songs, and each one is 99 cents. Go ahead and solve that and see how much that is. Pause it so that you can check it. Okay, so did you get $19.99 plus $1.98, which is $21.97? Okay, what if she purchases N songs? Okay, that could be 1, it could be 5, it could be 100, it could be 1,000. We don't know, but we can write an expression for the total cost. Remember, we still have that membership fee. So it's $19.99 plus, we don't know how many. We can write it as N times 99 cents, but usually you're not going to see it that way. Usually you're going to see it like this. 99 cents times N. Okay, so to get used to seeing it algebraically, and even more so, a lot of times, most of the times, the variable term comes first, but it won't affect it because this is a positive 19.99 plus 99 cents times each song. Okay, part C says her friend has saved $118, but is not sure how many songs she can afford. Use the expression in part B to write an equation. So we're going to take this same expression right here, 1999 plus 9.99n, that's 99 cents per song. And she knows that she has $118 to spend. So we don't want this left side to be more than $118. So we're trying to figure out how many songs can she buy. And that's all you have to do for C. That was a long question, but it's just this equation. Okay, some of you may know how to solve this because it's a two-step equation. So if you do know how to solve it, that's great. What we're going to do in D is we're just going to plug a few things in to see which one of those is correct. So they give you three choices. They're telling you her friend can either buy 101, 100, or 99 songs. What we're going to do is we're going to plug each one of those in for this equation. Okay, and I'm actually going to just drag this equation here. And instead of n, I'm going to plug in those three numbers that they gave us. Okay, so we're trying to figure out, can her friend buy 101 songs? Can she buy 100 songs? Or can she buy 99 songs? Now, those were given to you. If you didn't know that, you might be guessing a lot to try to figure out how many songs she could buy. And like I said, in the future, we'll just be solving this equation, and it'll just be a quick solution. But for now, we're going to say, okay, can she buy 101? So go ahead, type that in, 101 times 99 cents, and then add in that 19.99 fee. Go ahead and write down what each of those equals. Okay, so you're basically figuring out how much would it cost for 101 songs, for 100 songs, and for 99 songs. Okay, pause it and then unpause it and see if your numbers match mine. Okay, for the first one, this one is $119.98. So is that $118? No. Okay, the second one for 100 songs, hopefully you got $118.99. Okay, we're close, but that's still over. She doesn't have enough money for that. And then the last one, did you get exactly $118? Okay, and there you go. So she can get 99 songs. Okay, go ahead and do your summary, and that is a wrap on lesson 7.